Hello students, in this video we are going to learn the important points of the chapter structure of atom from first PUC chemistry, 11 CBSE chemistry, and these points are going to be very useful for the coming Karnataka CET exam as well as the NEET exam. Let us start the chapter. So as we know, in atom there are three basic constituent particles: protons, electrons and neutrons. Protons discovered by J.J. Thomson, electron Goldstein and neutron Chadwick. And according to Michael Faraday, atoms is divisible, which means atom no longer non-divisible. So atoms are divisible, said by Michael Faraday. Let us learn some important points about cathode rays. Cathode rays basic constituent particles are electrons. Cathode rays are made up of electrons, and those electrons are the basic unit of atom. And cathode rays possess kinetic energy. Remember, they possess kinetic energy and produce heat and pressure. Cathode ray produce heat and pressure. And most important point is cathode rays are not electromagnetic waves. They are not electromagnetic waves, and as we know, cathode rays are negatively charged, so they move from cathode to positive electrode anode, and they travel in straight line when there is an absence of electric and magnetic field. And also remember, cathode rays do not depend on the material of the electrode, and they not move with the speed of light. So cathode rays speed is not equal to the speed of light. And in cathode ray discharge tube, we are going to fill the gas with low pressure and high voltage. And in this cathode ray discharge experiment, the fluorescent screen is made up of zinc sulfide ZNS. These are the important points related to cathode rays. And let us move to the next concept, oil drop experiment. So oil drop experiment done by Millikan, and he mentioned the charge of the electron with this experiment, that is 1 minus 1.6 into 10 to the power of minus 19 coulomb. And charge to mass ratio of electron, which is 9.1 into 10 to the power of minus 31 kg, was discovered by J.J. Thomson. And neutrons discovery was late because they do not carry any charge. So neutrons discovered by Chadwick. How he discovered? He passed alpha particles on a sheet of beryllium. When he passed alpha particles on the sheet of beryllium, neutrons are emitted, and these neutrons particles, they are not deflected by electric and magnetic field because they does not possess any kind of charge. So this is how the neutrons has been discovered. Now also remember about positron, and remember, positron are the lightest particle. They are the lightest particle, and they possess positive and they are also called as positive charge electron without mass. So positron are the lightest particles. They include positive charge electrons without mass. And also remember the penetrating power of alpha, beta and gamma rays, where alpha rays have low penetrating power and gamma rays have high penetrating power. And also remember the most important point, gamma rays and X-rays are not deflected by electric and magnetic field because they are made up of the particles which does not carry any kind of charge. That's why they are not deflected by electric and magnetic field. Now come to Thomson model of atom, which is also called as plum pudding model, also called as watermelon model. Here you remember only one point about this model, that this model explained about the overall neutrality of atom. So overall neutrality of atom explained by Thomson model of atom. Now come to Rutherford experiment. It is also called as alpha ray scattering experiment, where Rutherford passed the helium nuclei on the gold foil. Gold foil he is used because gold is highly malleable, and he found that most of the rays are undeflected. They passed through the atom without any deflection. Okay, and only minute particles are deflected with small angle, and some alpha rays around 1 in 20,000 they deflected, they bounce back. That indicates that in atom, nucleus occupies much smaller volume compared to the total volume of the atom. nucleus occupies much smaller position, much smaller volume. And he also mentioned that all the positive charge deposited in that small part called nucleus, because nucleus is made up of positive charge protons, and around the nucleus electrons are revolving in centrifugal force. Electrons revolves around the nucleus in the centrifugal force. Remember this word, centrifugal force. Now come to some basic formula which everybody knows, that if you consider X as an element, subscript Z is atomic number which is equal to the number of proton or electrons present in an atom, and superscript A is considered as atomic mass or mass number which is the total number of protons and neutrons present in an atom. And number of neutrons can be calculated by subtracting atomic mass minus atomic number. For example, if you take calcium whose atomic number is 20 and mass number is 40, then we can conclude that calcium has 20 protons or 20 electrons, and the number of neutrons can be calculated by subtracting atomic mass with atomic number, that is number of neutrons 20. And in the nucleus, as it is made up of proton and neutron, that is called as nucleons. So nucleons is a combination of proton and neutron. Now remember, during alpha decay there is a decrease in the atomic number by 2 and decrease in atomic mass by 4. During alpha decay the atomic number is decreased by 2 and atomic mass is decreased by 4. Now isotopes means atoms of the same species having same atomic number but different mass number. Similarly, isobars are the atoms of different elements having different atomic number but same atomic mass. They are the isobars. And remember, same atomic number responsible for same chemical properties. Same atomic number responsible for the similar chemical properties. Now let us know few points about electromagnetic spectrum. So electromagnetic spectrum is the arrangement of different electromagnetic radiation in the increasing order of wavelength or decreasing order of frequency. Remember, increasing order of wavelength or decreasing order of frequency, as you can see here. So gamma rays to radio waves, we have arranged them in the increasing order of wavelength or decreasing order of frequency, so that you remember about the electromagnetic spectrum. Now the formula that shows the relationship between velocity, wavelength and frequency is this, where this formula is the about wave number which is reciprocal of wavelength. Now important topic about black body radiation. So black body radiations means these emits or absorbs radiations of all the frequency. All frequency radiations emits or absorbs by black body. Those radiations are called as black body radiations, emits or absorbs the radiations of all frequency. Now remember about this graph. This graph indicates wavelength versus intensity. So as you increase the temperature, intensity also increases. Intensity of the black body radiation also increases. So this graph is related to black body radiation. Very important to the exam. And remember about Planck's quantum theory. Planck's quantum theory says that energy emits or absorbs as a small pockets called quanta or photon, and that formula is energy E is equal to H Planck's constant into V frequency, and this explains the wave nature and particle nature of an electron, and this is a value of Planck's constant H value. Now come to photoelectric effect. So it says that when a light of suitable frequency falls on the surface of the metal ejects electron. When the light of the suitable frequency falls on the surface of the metal, electrons are going to eject. That is called photoelectric effect. Now this shows that as the size of the atom increases, ejection also increases. Photoelectric effect also increases. So intensity increases with the increase in the number of electrons ejection. Intensity increases with the increase in as the intensity increases, the number of electrons ejected from the metal surface also increases. And remember, photoelectric effect happens only when the frequency of the light is greater than the threshold frequency, and energy emitted by electron is smaller than incident photon, and electron's energy is less than the frequency of incident frequency. So these points are important related to photoelectric effect. So now Bohr's theory, remember Bohr's theory is applicable only to the atoms or ions having one electron. So these are the examples of the atoms and hydrogen atom and other ions which carries one electron. For them Bohr's theory is applicable. And according to this theory, angular momentum can be calculated with the formula nh by 2 pi. nh by 2 pi. H is a Planck's constant and n is a principal quantum number. And when according to Bohr's theory, when electron jumps to higher orbit, it absorbs the energy, and when electron jumps to lower orbit, it emits the energy. That you remember. And to calculate the radius of any orbit, we have a formula Rn is equal to R1 into n square, where R1 value, the radius of first orbit, is 53 picometer or 0.53 Armstrong. And particle nature of electron is experimentally determined by J.J. Thomson. And remember, here I have mentioned the definitions of Zeeman's effect and Stark's effect. Zeeman effect is a splitting of spectral line in the presence of magnetic field, and Stark's effect is the splitting of spectral line in the presence of electric field. So in the presence of magnetic field, Zeeman's effect. A splitting of spectral in the presence of electric field is Stark's effect. Now remember about the hydrogen spectrum. According to N1, if N1 is equal to 1, it is Lehman series which carries UV radiation. If N1 value is 2, it is Balmer series, it is visible region. And N3, N is equal to 3, Paschen, IR, N is equal to 4, bracket IR, N is equal to 5, Fund, IR. So here remember Lehman series UV region and Balmer series visible region. Remaining 3, Paschen, bracket and Fund, includes to infrared radiation. And this is the formula to calculate energy difference when electron jumps from higher to lower or lower to higher. Our wave number is equal to RH into Rydberg constant, RH into 1 by n1 square minus 1 by n2 square. And remember, when electron jumps from N3 to N2, it emits maximum energy, and when electron jumps from N6 to N5, it emits least energy. So this is about hydrogen spectrum, important points. Now come to de Broglie equation. De Broglie equation explains about the dual nature of the particle. Which are the dual nature? Particle nature and wave nature. Both is explained by de Broglie equation, and the formula of de Broglie equation is wavelength is equal to h by mv. H is Planck's constant, m is mass, and v is velocity, also called as h by p. P is momentum. So also remember here, if n is the number of shell, n square is the number of orbit. If n is the number of shell, for example k, n value is 1, n square is the number of orbits. N square is the number of orbits. To calculate the number of orbitals in the orbit, to calculate the number of orbitals in the in the shells, use this formula. N is number of orbit or number of shells, and n square is the number of orbitals. SPDF. Now energy of Bohr's orbit, we can calculate with these formulas. So sometimes in JEE exam they'll ask the numericals related to these formulas. Please remember. Now come to the quantum numbers. There are 4 quantum numbers: principal, azimuthal, magnetic, and spin quantum number. So principal quantum number explain about the size or energy of the orbital, and azimuthal quantum number explains about the shape of the orbital. Formula is L is equal to n minus 1. Magnetic quantum number explains the orientation of the orbital. Value of magnetic quantum number is minus L, 0 to plus L. And spin quantum number explain about the spin of electron, where electrons can move either in clockwise direction or in anti-clockwise direction. Remember about Aufbau principle. In Aufbau principle, electrons enters in the increasing order of energies, n plus L value, principal plus azimuthal quantum number value. And Aufbau principle is not correct for chromium and copper, because they are not going to follow the normal electronic configuration. Then remember Hund's rule. Hund's rule of maximum multiplicity. Here I have given the example of nitrogen. So nitrogen electronic configuration 2 I have mentioned. One is right, one is wrong. So electron pairing. So p orbitals px, py, pz both all the three have same energy. So electron pairing will not possible until all the orbitals occupies electron singly. So this pairing is not possible. That's what Hund's rule says. And Heisenberg uncertainty principle also very important. It is says that it is impossible to determine the exact position and momentum of electron. And to nodes means remember nodes means it is in atomic orbital there is a probability of finding the electron is 0. Those regions are called as nodes. So there are two types of nodes, radial nodes and angular nodes. So nodes can be calculated with the formula n minus L, principal quantum number minus azimuthal quantum number. Whereas radial nodes can be calculated with the formula n minus L minus 1 and angular nodes is equal to azimuthal quantum number. So these are the important points related to the structure of atom chapter. If you revise this, I hope will be very helpful to write the Karnataka CET exam. Thank you, students.